In this video, we're going to use a process called substitution to solve equations that are quadratic in form. It's a little different. So let's take a look at the first one. I'm not going to read through the steps. I will refer to them as we go through. So it says to define a variable u and write each equation in the form of, and then we see some number times u squared plus some number times u plus c equals 0, then solve. So let me explain what we're doing. This equation, rather than being x squared, is x to the fourth minus 13x squared plus 36 equals 0. So what we're going to say is we're going to let the letter u, and I don't know why, but u is always the letter that's used, let u be equal to x squared. And I got that from my middle term. Whatever that middle term is without its coefficient is what I'm going to let u be. Well, if u is x squared, then that would become negative 13u plus 36. And then u is equal to x squared, so u squared would be x to the fourth. And now what you have is an equation that you recognize. It's quadratic. Its highest exponent is a 2. So now I can solve this by any of the methods I know for solving. It's not a good candidate for the square root property. It's not a good candidate, in my opinion, for completing the square because my middle term is odd. So I'm going to try factoring, and if that doesn't work, I'll use the quadratic formula. So I need factors of positive 36 that combine to make negative 13. I believe that is negative 9 and negative 4. That gives me u minus 9 times u minus 4 equals 0. Using the zero factor property, I say either u minus 9 equals 0 or u minus 4 equals 0. I solve those two little equations and I get u equals 9 or u equals 4. Now, this is the part that's very different from anything you've probably ever done before. We are not trying to solve for u. We're trying to solve for x. But we let u be a stand-in for x squared. So u is 9 is a stand-in for x squared. So if u equals x squared and u equals 9, then the stand-in x squared equals 9. U is equal to x squared and u is equal to 9, so x squared has to equal 9. So to solve that now, I can take the square root of both sides and I get x equals plus or minus 3. So there's two answers. Now I'm going to go to u equals 4, but u is a stand-in for x squared, so that must mean x squared equals 4. Take the square root of both of those and I get x equals plus or minus 2. So you'll notice if I show it in set notation, my answers are negative 3, negative 2, positive 2, and 3. I have 4 answers, and this exponent here, x to the fourth, gave me the clue that I should get 4 answers. Let's try another one. This other one's a little different because of the way that it's set up. We have 2 times 4x minus 3 quantity squared plus 7 times 4x minus 3 plus 5 equals 0. Well, what you don't want to do is FOIL this out and then distribute a 2 and distribute a 7 and combine like terms and end up with something that could possibly be just a big mess. So we're going to say, again, let u equal this middle term right here, not with its coefficient, but just this part. So it's going to equal 4x minus 3. So what that means is I have a 2, take out the 4x minus 3 and put in the u squared, plus 7, take out the 4x minus 3, u plus 5 equals 0. And I have a much simpler equation to solve. This is a long process factoring if it's factorable. So I would say 2 times positive 5 is positive 10, and I want factors that add up to positive 7. I believe it is factorable, positive 5 and positive 2. So I'm going to bring down, this is the long process, break down my 7u into these two pieces, plus 2u plus 5u plus 5, bring down my last one, group, making two binomials with a plus in between. The GCF of the first binomial is 2u, and I'm left with u plus 1. Bring down my plus. The GCF of the second binomial is 5, and I'm left with u plus 1. So my first factor is u plus 1, and my second factor is 2u plus 5. Using the zero factor property, I say either u plus 1 equals 0 or 2u plus 5 equals 0. Solving, I get u is negative 1, or here I'm going to subtract a 5 and divide by 2, and I get u equals negative 5 halves. Now remember, we weren't looking for u, we just had to find the u's first, here it is right here, before we could find the x's. But these u's are just stand-ins for 4x minus 3. So that means negative 1 was a stand-in. So I'm going to write 4x minus 3. So I took the u away because it's a stand-in and put the 4x minus 3 in its place. Now I'm going to solve this equation. I get 4x equals 2. Divide by 4, and I get x equals 1/2. Now there's an answer that isn't x equals. So let's do it again. U is equal to 4x minus 3, but u is negative 5 halves, and u is just a stand-in for 4x minus 3, so 4x minus 3 is equal to negative 5 halves. This one's a little bit harder to solve. We're going to add a 3 to both sides. 4x equals 3, whoops, that's a minus, sorry, 3 minus 5 halves. Now I need to find a common denominator to combine those. So that's going to be 2. So I'm going to have 6 halves minus 5 halves. So 4x equals 6 halves, take away 5 halves is 1/2. Now I have to divide both sides by 4. Notice how I wrote it on this side since it's a fraction. And I get x equals 1/2 divided by 4 is, keep, change, flip, x is 1/8. And I have my second answer. And I did it, it's kind of a manipulation. We are, rather than dealing with these long pieces that when foiled would make for a lot of terms and a kind of a mess, we're just substituting, and we're using that middle term to tell us what we're going to let u be, and then the other one becomes u squared.